Let's now take a look at the objectives of the session. At the end of the session, you will be able to state the basic safety signs, identify the basic categories of safety sign, state personal safety measures, state what is 5S, list the benefits of 5S, methods of waste disposal, identify and segregate the waste material in workshop, arrange the waste material in different bins. Now let us look at the safety signs, which are mainly classified into 4 categories. They are prohibition signs, mandatory signs, warning signs, information signs. These categories of safety signs can be recognized based on the following colors: red, yellow or amber, blue, green. Now let us look at each one of these in detail. Red-colored safety signs usually include prohibition signs, dangerous behavior, stop, shut down, evacuate signs, fire safety signs. Yellow or amber-colored safety signs usually include warning signs, be careful, take precautions, examine signs. Blue-colored safety signs usually include mandatory signs, specific behavior or action, wear protective equipment signs. Green-colored safety signs usually include emergency escape, first aid signs, doors, exits, escape routes, equipment and facilities signs. Next, let us learn about prohibition signs. Prohibition signs indicate an action or behavior that is not permitted in the workplace. The signs are shown as a red circle with a red slash over a black icon of the action. The text is black on a white background. Next, let us learn about the mandatory signs. Mandatory signs provide specific instructions that must be carried out. The icons are in white over a blue circle. The text is black on a white background. Next, let us learn about warning signs. Warning signs warns of hazards or conditions that require special attention. These safety signs consist of a black triangle and an icon on a yellow background with black text. Next, let us learn about emergency signs. Emergency signs are general information signs which indicate the location or directions to emergency facilities. These signs feature a white symbol or text on a green background. Next, let us learn about information signs. These signs communicate information which is general in nature. These are shown by having a white icon with a blue background. The text is written in black. Next, let us learn about fire safety signs. Fire safety signs advise the location of fire alarms and firefighting equipment. They contain white symbols or text on a red background. Now let us know about housekeeping and waste disposal. Housekeeping is not just cleanliness, it includes keeping work area neat and orderly, maintain floors free of slip, removing waste materials and other fire hazards in work area. 5S is a Japanese methodology for workplace organization. In Japanese, it stands for seiri, sort, seiton, set in order, seiso, shine, saiketsu, standardize, and shitsuke, sustain. Sort. The first S focuses on eliminating unnecessary items from the workplace that are not needed for current production operations. A red tag is placed on all items that are not important for operations or that are not in the proper location or quantity. Set in order. The second S. Once the red tag items are identified, these items are then moved to a central holding area for subsequent disposal, recycling, or reassignment. Shine. Once the clutter that has been clogging the work areas is eliminated and remaining items are organized, the next step is to thoroughly clean the work area. Standardize. Once the first 5 S's have been implemented, the next pillar is to standardize the best practices in the work area. Sustain. Making a habit of properly maintaining correct procedures is often the most difficult S to implement and achieve. The benefits of the 5S system are increases in productivity, increases in quality, reduction in cost, improves morale of the works and reduces accident. It gives satisfaction to customers. It enables overall improvement, better hygienic condition leading to improved health. Now let us know about disposal of waste material. Industrial waste is the waste produced by industrial activity such as mills, mines, and factories. Typical list of industrial waste material: cotton waste, metal chips of different material, oily waste such as lubricating oil, coolant, etc., other waste such as electrical, glass, etc. Methods of waste disposal. Recycling. Recycling of waste is any recovery operation by which waste materials are reprocessed into products, materials, or substances, whether for original or for other purposes. Compositing. This is a natural process that is completely free of any hazardous byproducts. This process involves breaking down the materials into organic compounds that can be used as manure. Landfills. Waste management through the use of landfills involves the use of a large area. This place is dug open and filled with the waste. Burning the waste material. If you cannot recycle or if there are no proper places for setting up landfills, you can burn the waste matter generated in your household. Controlled burning of waste at high temperatures to produce steam and ash is a preferred waste disposal technique. First step of disposal of waste material involves collection and segregation of the waste. Once after collecting the waste, separate the cotton waste. Collect the chips by hand shovel with help of a brush. Do not handle the chip by bare hand. There may be different metal chips, so separate the chip according to the metal. Separate the cotton waste material and store in the bin provided to store the waste cotton material. Similarly, Store each category of metal chip in separate bins. Color code for bins for waste segregation. For paper, it is blue. For plastic, it is yellow. For metal, it is red. For glass, it is green. For food, it is black. And for others, it is sky blue. To recap, we have learned to state the basic safety signs, identify the basic categories of safety sign, state personal safety measures, state what is 5S, list the benefits of 5S, methods of waste disposal, identify and segregate the waste material in workshop, arrange the waste material in different bins.
So that's all about safety signs for danger, warning, caution and personal safety message and safe disposal of waste materials. See you in the next session. Hello and welcome to this session on preventive measures for electrical accidents and steps to be taken in such accidents. Let us begin with the session.
Let us now take a look at the objectives of the session. At the end of the session, you will be able to define an electric shock, define the effects of electric shock, define actions to be taken during electric shock to treat the victim, define safety measures around electrical equipment, disconnect a person from a live electric wire. First, let us understand what an electric shock is. If a person happened to come in contact with an electrical live wire, and if he has not insulated himself, then electric current flows through his body. The severity of an electric shock depends on the level of current passing through the body. How long does the current keep passing through the body? Therefore, the higher the current or longer the time, the shock may result in a casualty. In addition, other factors which influence the severity of shock are age of the person receiving a shock, surrounding weather condition of the floor, wet or dry, voltage and current level, insulating property of the different equipment. Next, let us look into the effects of electric shock. The effects of electric shock may vary at different current values. A current of 1 milliampere to 5 milliampere is of low risk and provides a tingling sensation. A current of 10 milliampere to 300 milliampere is of moderate risk and can lead to sustained muscular contraction and ventricular fibrillation. A current of 300 milliampere and above is of high risk and can lead to defibrillation and burns. The effect of electric shock at very low current levels of 1 milliampere to 5 milliampere may only be an unpleasant tingling sensation. But this shock itself may be sufficient to cause someone to lose his balance and fall, resulting in casualty. At higher current levels of 10 milliampere to 300 milliampere, the muscles may contract and the person will be unable to break off from the contact by himself. He may lose consciousness. Even the muscles of the heart may contract. At an excessive current level of 300 milliamperes and above, the person receiving a shock may be thrown off his feet and will experience severe pain and possibly burns at the point of contact. This in most cases is fatal. Let us learn about actions to be taken in case of an electric shock. If the victim of an electric shock is in contact with the supply, choose the appropriate non-electrical conducting material to release the person from electrical contact, such as wood or rubber. Switch off the electrical power, insulate yourself and pull away the person from the electrical contact. Or remove the mains from electrical plug. Avoid direct contact with the victim. Wrap your hands using dry cloth or paper if rubber gloves are not available. Instead, break the contact between the victim and the electrical source by using an insulated tool such as dry wood log. Another alternative is to stand on some insulating material such as dry wood, rubber, plastic or whatever is at hand to insulate yourself and break the contact by pushing or pulling the person or the cable, equipment or point free. Ensure your personal safety with utmost priority. If the victim is working on a pole or at a raised place, take suitable measures to prevent him from falling or at least ensure that his fall is safe. Cover the burnt area with a sterile dressing. Get a doctor's help to treat him as quickly as possible. If the victim is unconscious after an electric shock, immediately prepare to give him or her the first aid. Ensure that the rescuers are well trained in first aid. After that, immediately send him or her for medical treatment. Next, let us look at the safety measures related to electrical equipment. Only qualified, trained persons should do electrical work. Do not work on live circuits. If unavoidable, use rubber gloves, rubber mats, etc. Use insulated handle screwdrivers and pliers while working on electrical circuits. Do not touch bare conductors. Stand on rubber mats while working, operating switch panels, control gears, etc. Now let us look at the procedure for disconnecting a person from a live supply. Observe the person, mock victim, receiving an electric shock. Interpret the situation quickly. Remove the victim safely from the live equipment by disconnecting the supply or using one of the items of insulating material. Move the victim physically to a safer place. If victim is in unconscious stage, then loosen the clothing of neck, chest and waist and place the victim in a relaxed position. Check for the victim's natural breathing and consciousness. Give first aid by a trained rescuer based on the condition and immediately send the victim for medical treatment. Keep the patient warm. In case of electric burns or injury, do the first aid. Clean the burnt area with water. Cover the burnt area by sterile cloth. In case of severe bleeding, Make the patient lie down and rest. If possible, raise the injured part above the level of the body. Apply pressure on the wound as long as necessary to stop the bleeding. Put a dressing over the wound and cover it with a pad of soft material. If bleeding is severe, apply more than one dressing. Proceed to perform the right methods of artificial respiration. To recap, we have learned to define an electric shock, define the effects of electric shock, define actions to be taken during electric shock to treat the victim, define safety measures around electrical equipment, disconnect a person from a live electric wire.
So that's all about preventive measures for electrical accidents and steps to be taken in such accidents. See you in the next session. Hello and welcome to the session on use of fire extinguishers. Let us begin with the session.
Let us now take a look at the objectives of the session. At the end of the session, you will be able to define fire and fire extinguishers, identify types of fires and fire extinguishers, state the procedure for using fire extinguishers. First, let us learn about fire. Fire is the burning of combustible material. A fire in an unwanted place or occasion and in uncontrollable quantity can cause damage or destroy property and materials. Fire can be stopped by eliminating any one of the three factors, namely fuel, heat, and oxygen. These factors must be present as a combination for a fire to continue to burn. Let us look at each of these briefly. Fuel. Any substance, liquid, solid, or gas will burn if enough oxygen and heat are given. Heat. This ignites the fire when the fuel reaches its flash and fire point temperature. Oxygen. Usually, oxygen exists in sufficient quantity in air to keep a fire burning. The air contains 21% of oxygen. There are three basic ways of achieving this: starving the fire, smothering the fire, cooling the fire. Starving the fire of fuel by removing the fuel in the vicinity of fire. Smothering. Smothering is done by isolating the fire from the supply of oxygen by blanketing it with foam, sand, etc. Cooling. Cooling is done by using water to lower the temperature. Now let us learn how to prevent fires. The majority of fires begin with small outbreaks which burn unnoticed until they become big fires of uncontrollable magnitude. Highly flammable liquids and petroleum mixtures should be stored in a separated place called the flammable material storage area. Next, let us look at the classification of fires and recommended extinguishing agents. Fires are classified mainly into 4 types based on nature of fuel as Class A, B, C, and D. Further fires related to electrical and kitchen hazards are subclassified as Class E and Class F respectively as shown below. Let us now look at what an extinguishing agent is. An agent is the material or substance used to put out the fire and is usually but not always, contained in a fire extinguisher with a mechanism for spraying into the fire. It is important to know the right type of agent for a particular type of fire. Using the wrong one can make things worse. Let us now look at what fire extinguishers are. A fire extinguisher is an active fire protection device used to extinguish or control small fires, often in emergencies. Many types of fire extinguishers are available with different extinguishing agents to deal with different classes of fires. There are mainly 5 types of fire extinguishers. They are water, foam, powder, carbon dioxide, wet chemical. Let us look at each of these in detail. First, let us look at water-based extinguishers. Water-based extinguishers are very common and should be used on solid materials only. This can include paper, wood, or any other solid fuel. Water-based extinguishers are essentially filled with water and use compressed air to help this come out. Some will also have an additive that will help make them more effective. Let us now look at foam extinguishers. Foam extinguishers are used on burning liquids such as petrol or diesel fires. They can also be used on solid fuel fires in the same way as water extinguishers. Foam fire extinguishers are water-based, therefore they can be used on solid fuels and have a cooling effect. They also contain aqueous film-forming foam which smothers the fire and seals in any flammable vapors. This will prevent the fire from reigniting and is why they are used to treat flammable liquids. Let us now learn about carbon dioxide extinguishers. Carbon dioxide extinguishers are typically used on electrical equipment. They can also be used to extinguish flammable liquids in the same way as foam extinguishers. Carbon dioxide extinguishers are not generally effective in open air. Since carbon dioxide extinguishers are perfect for electrical fires, they are commonly found in offices or places where there is a lot of electrical devices. Carbon dioxide extinguishers use black label. Next, let us learn about dry powder extinguishers. Dry powder extinguishers can be used on most fire types, including electrical devices. Dry powder fire extinguishers can be used on fire types A, B, and C. It can also be used to extinguish type D fires on metals such as magnesium and titanium. Dry powder extinguishers use a blue label. Next, let us look at wet chemical extinguishers. Wet chemical extinguishers are specifically designed to be used on fires that have cooking oils and fats as their fuel. This type of extinguisher both cools and smothers the fire. This is not to be used on flammable liquids, flammable gases, flammable metal, and electrical fires. Wet chemical extinguishers use a yellow label. Next, let us look at the procedure of working on fire extinguishers. There are mainly 3 steps involved in this procedure. Step 1. Alerting. Step 2. Identification of fire type. Step 3. Extinguishing the fire. Let us look at each of these steps in detail. First, let us look at the alerting stage. Alert people surrounding by shouting "Fire! Fire! Fire!" when observe the fire. Inform fire service or arrange to inform immediately. Open emergency exit and ask them to go away. Put off electrical power supply. Do not allow people to go nearer to the fire. Once after alerting people and authorities, identify the type of fire. Now, assuming it's type B fire, use carbon dioxide fire extinguisher. After locating and picking up carbon dioxide fire extinguisher, check for its expiry date. Break the seal. Pull the safety pin from the handle. Aim the extinguisher nozzle or hose to the base of the fire. Keep yourself low. Squeeze the handle lever slowly to discharge the agent. Sweep side to side approximately 15 cm over the fuel fire until the fire is put off. To recap, we have learned to define fire and fire extinguishers, identify types of fires and fire extinguishers, state the procedure for using fire extinguishers.
So that's all about use of fire extinguishers. See you in the next session. Hello and welcome to this session on practice and understanding precautions to be followed while working in fitting jobs. Let us begin with this session.
Let us now take a look at the objectives of this session. At the end of this session, you will be able to learn and practice fitting jobs, learn the precautions to be observed in fitting jobs, record the precautions to be followed while working in fitting jobs. Tools required for this exercise are bench vise, files, hacksaw blade with frame, chisel, ball peen hammer, anvil, flatter tool, sledgehammer, tongs, grinding machine, belt drive of a lathe, wire brush, pulley with belt arrangement on a drilling machine, pedestal grinding machine. Let us learn about fitting. Fitting is related to the assembly of parts after bringing the dimensions or shape to the required size or form in order to secure the necessary fit. The operations required for fitting are usually carried out on a workbench. The various operations performed in a fitting shop are marking, chipping, sawing, filing, scraping, drilling, thread cutting, etc. Let us learn the postures and procedures to be followed for practicing fitting jobs. Ensure that the height of the bench vise is around the waist height of the user. Hold the job in the bench vise with a projection of minimum 5 to 10 mm from the top of the vise. Standing position. Left leg in front and right leg back at a distance of about 1 foot between the right and the left legs. Guiding. Right hand on the file handle and left hand on the top of the file face. Handling the file. Never apply pressure during the pull or draw stroke. Prevent pinning or clogging the file teeth with debris or files by rubbing the face of the file with chalk before starting the operation. Pressing too hard on the file also causes pinning. Files should be cleaned on a regular basis by using a card brush. files should be stored so that their faces cannot rub each other. Select suitable files for the filing work. Let us learn about the precautions to be observed in fitting jobs. Fit the wooden or plastic handle for the files. Hold the job on the vise firmly. Do not use the file without a handle. Check whether the handle of the file is fitted tightly. Avoid storing of tools or any other material on the bench vise. Let us now record the precautions to be followed while working in fitting jobs. Precaution number 1. Keep the shop floor as well as the workbench free from accumulation of dirt, oil and scrap every day. Precaution number 2. Ensure that every moving component of a machine is protected with a guard to avoid any accidents. Precaution number 3. Never use a file or a hacksaw frame without a handle. Precaution number 4. Never employ the side face of a grinding wheel to sharpen a chisel or any other tool. Precaution number 5. Always ensure that the heat-resistant leather gloves are used while handling hot jobs like that of forging, etc. Precaution number 6. Never chip with a blunt chisel or a mushroom head chisel. Precaution number 7. Do not strike on the handle of a bench vise or machine vise to tighten the grip on the workpiece. Precaution number 8. Always keep the machine and its surrounding areas free from metal chips, oil, etc. Precaution number 9. Do not attempt to change the spindle speed of a machine while in running condition. Precaution number 10. Always ensure that a chipping screen is in place while chipping on a metal. To recap, we have learned to learn and practice fitting jobs, learn the precautions to be observed in fitting jobs, record the precautions to be followed while working in fitting jobs.
So that's all about practice and understand precautions to be followed while working in fitting jobs. Hope you have understood all the concepts and exercises. See you in the next session. Hello and welcome to the session on identification and function of different parts of lathe and practicing idle run. Let us begin with the session.
Let us now take a look at the objectives of this session. At the end of this session, you will be able to identify the main parts of a lathe, understand the functions of the parts of a lathe, identify the lubrication points in the lathe, set the spindle speed and lever position in lathe. Machine tools are run by machines for performing machining operations such as turning, drilling, milling, grinding, etc. A lathe is a machine tool that rotates a workpiece about an axis of rotation to perform various turning operations with tools that are applied to the workpiece to create an object with symmetry about the axis. The workpiece of a lathe is held and rotated in the chuck. The cutting tool is rigidly held and supported in a tool post and fed against the revolving job. Let us now identify the main parts of a lathe and its functions. Headstock. It houses the spindle speed, change mechanism and gears and must be built robustly. Tailstock. It is a casted movable part mounted on the guideways of the bed, positioned opposite to the headstock and supports the workpiece during machining. Carriage. It serves as a guide, supports and feeds the tool against the workpiece and is positioned in between the headstock and tailstock. Saddle. It is a casted component positioned on top of the carriage which supports the cross slide, compound rest and tool post. Cross slide. It is positioned on top of a saddle and its hand wheel is turned to move the cross slide perpendicularly to the axis of the lathe. Compound rest. It joins the cross slide with tongue and groove joint and supports the cutting tool and tool post. Tool post. It is mounted on the compound rest and is used to carry cutting tools and the tool holders. Feed rod. It is a power transmission mechanism which is used for precise carriage movement along the axis. Lead screw. It is used to move the carriage along with the revolution of the spindle. Gearbox. It is equipped with a series of gears which provides a range of feeds and threads to the machine. Bed. It is a casted part and serves as the foundation upon which all other components of the lathe are installed. Leg. The bed is mounted on the legs which are bolted to the ground. Chuck. It is a work holding device used to clamp the job. Let us now identify the moving parts along with the direction of the movement. When the carriage wheel is turned in anti-clockwise direction, the carriage moves towards the headstock. When the carriage wheel is turned in the clockwise direction, the carriage moves towards the tailstock. When the cross-slide handle wheel is turned in the clockwise direction, the cross-slide moves towards the headstock in the forward direction. When the cross-slide handle wheel is turned in the anti-clockwise direction, the cross-slide moves away from the headstock in the backward direction. Sweeling the compound rest in the anti-clockwise direction will taper turn the job such that the diameter will increase towards the chuck. Let us now identify the lubrication points in the lathe. The lathe has lubricating points on the following parts: headstock, carriage, compound rest, tailstock, feed rod, lead screw, gearbox. Let us now identify the levers and their positions on a lathe. The following are the major levers and their positions on a lathe. Headstock, spindle speed selector lever, gear levers, motor control lever. gearbox. Feed drive for carriage, feed drive for cross slide. Carriage. Half nut operating lever for thread cutting using the lead screw. Let us now learn how to operate the lathe on idle. Ensure the smooth movement of the carriage. Ensure the smooth movement of the cross slide. Ensure the smooth movement of the compound rest. Ensure the smooth movement of the tool post. Ensure the smooth movement of the tailstock. Ensure the smooth movement of the carriage. Ensure that the tip of the cutting tool and the tip of the center of the tailstock are in the same plane. Lubricate on all the lubrication points before switching on the lathe. To recap, we have learned to identify the main parts of a lathe, understand the functions of the parts of a lathe, identify the lubrication points in the lathe, set the spindle speed and lever position in lathe.
So that's all about identification and function of different parts of lathe and practicing idle run. Hope you have understood all the concepts and exercises. See you in the next session. Hello and welcome to this session on setting lathe on different speed and feed. Let us begin with the session.
Let us now take a look at the objectives of this session. At the end of this session, you will be able to identify the speed on the lathe, select the speed and feed, tabulate the speed and feed in the respective tables. Let us learn about cutting speed, feed and depth of cut. The cutting speed of a cutting tool can be defined as the rate at which its cutting edge passes over the surface of the workpiece in unit time. It is expressed in meters per minute. Feed of the cutting tool is defined as the distance it travels along or into the workpiece for each pass in unit time. Depth of cut is the penetration of the cutting edge of the tool into the workpiece material in each pass. It determines the thickness of the metal layer removed by the cutting tool in one pass. The speed and feed of the cutting tool is influenced by material being machined, material of the cutting tool, geometry of the cutting tool, required degree of the surface finish, rigidity of the machine tool being used, type of coolant being used. Let us now learn to select the different spindle speeds on the lathe with the given set of gears. To obtain a speed of 1600 rpm, select the combination of D, R, E. To obtain various spindle speeds, the following gear combinations can be employed. For set of gears ASE, the spindle speed is 228 rpm. For set of gears ASF, the spindle speed is 38 rpm. For set of gears BSE, the spindle speed is 360 RPM. For set of gears BSF, the spindle speed is 60 RPM. For set of gears ARE, the spindle speed is 450 RPM. For set of gears ARF, the spindle speed is 71 RPM. For set of gears CSE, the spindle speed is 580 RPM. For set of gears CSF, the spindle speed is 90 RPM. For set of gears BRE, the spindle speed is 740 RPM. For set of gears BRF, the spindle speed is 115 RPM. For set of gears DSE, the spindle speed is 800 RPM. For set of gears DSF, the spindle speed is 140 RPM. For set of gears CRE, the spindle speed is 1150 RPM. For set of gears CRF, the spindle speed is 200 RPM. For set of gears DRE, the spindle speed is 1600 RPM. For set of gears DRF, the spindle speed is 250 RPM. Let us now learn about setting various feed rates on the lathe. Z is the lever for change in feed direction. Y is the lever for left hand and right hand thread cutting. G and H are tumbler gears. K, L and M are the levers for setting threads per inch (TPI) for the thread being cut. 1 to 6 knob for selection of feed thread pitch. To obtain a feed rate of 0.07 mm per revolution, set the tumbler gear to G. Forward feed direction in Z. Feed thread pitch knob at 6. Thread per inch lever to K. To obtain various feed rate, the following combinations can be employed. For Z in forward direction, with this gear combination, feed thread pitch at 6, tumbler gear G, feed rates of 0.07, 0.13 and 0.27 mm per revolution respectively can be obtained for K, L and M. Similarly, for the combination of Z6H feed rates of 0.53, 1.07 and 2.13 mm per revolution respectively can be obtained for K, L and M. For combination Z2G feed rates of 0.08, 0.16 and 0.32 mm per revolution respectively can be obtained for K, L and M. Similarly, for the combination of Z2H feed rates of 0.64, 1.27 and 2.54 mm per revolution respectively can be obtained for K, L and M. For the combination Z3G feed rates of 0.09, 0.18 and 0.36 mm per revolution respectively can be obtained for K, L and M. Similarly, for the combination Z3H feed rates of 0.71, 1.42 and 2.84 mm per revolution respectively can be obtained for K, L and M. For the combination Z5G feed rates of 0.11, 0.23 and 0.46 mm per revolution respectively can be obtained for K, L and M. Similarly, for the combination Z5H feed rates of 0.91, 1.82 and 3.66 mm per revolution respectively can be obtained for K, L and M. For the combination Z4G feed rates of 0.12, 0.25 and 0.5 mm per revolution respectively can be obtained for K, L and M. Similarly, for the combination Z4H feed rates of 0.99, 1.98 and 3.96 mm per revolution respectively can be obtained for K, L and M. For Z in backward direction, with this gear combination, feed thread pitch at 6, tumbler gear G feed rates of 0.05, 0.1 and 0.2 mm per revolution respectively can be obtained for K, L and M. Similarly, for the combinations Z6H feed rates of 0.4, 0.8 and 1.6 mm per revolution respectively can be obtained for K, L and M. For the combination Z2G feed rates of 0.06, 0.11 and 0.23 mm per revolution respectively can be obtained for K, L and M. Similarly, for the combination Z2H feed rates of 0.45, 0.9 and 1.8 mm per revolution respectively can be obtained for K, L and M. For the combination Z3G feed rates of 0.7, 0.13 and 0.25 mm per revolution respectively can be obtained for K, L and M. Similarly, for the combination Z3H feed rates of 0.5, 1.0 and 2.0 mm per revolution respectively can be obtained for K, L and M. For the combination Z5G feed rates of 0.08, 0.16 and 0.32 mm per revolution respectively can be obtained for K, L and M. Similarly, for the combination Z5H feed rates of 0.65, 1.3 and 2.6 mm per revolution respectively can be obtained for K, L and M. For the combination Z4G feed rates of 0.09, 0.18 and 0.35 mm per revolution respectively can be obtained for K, L and M. Similarly, for the combination Z4H feed rates of 0.7, 1.4 and 2.8 mm per revolution respectively can be obtained for K, L and M. To recap, we have learned to identify the speed on the lathe, select the speed and feed, tabulate the speed and feed in the respective tables.
So that's all about on setting lathe on different speed and feed. Hope you have understood all the concepts and exercises. See you in the next session.
Good morning, everyone. In Chief India Air Force Gandhinagar, from the Architect Division, a conscious effort has been made to improve the aesthetics of MAS buildings. Though the planning of the MAS buildings are very efficient, very good, because a lot of brainstorming goes into the planning aspects of this. However, the ultimate outcome is not the face of the building.